Recently, OpenAI's O1 model has been incredibly popular, and its reasoning capabilities far surpass those of GPT-4. In this video, I'll help everyone understand the technology behind this model and its future applications in a simple and approachable way. The core of this model lies in its powerful reasoning capabilities. To start, let's look at the process from fast thinking to slow thinking. When humans solve complex problems, we typically use a slow thinking process. For example, when faced with a challenging problem, we usually provide an initial solution. If that solution doesn't work, we think of another one, continuing until we arrive at a satisfactory result. We don't arrive at the desired answer in one step. In contrast, current large language models primarily rely on fast thinking. For example, when given a prompt, the model directly generates a response without an internal process of reasoning. We all know, however, that reasoning is crucial for solving complex problems. If we want to improve a large model's reasoning capabilities, we must teach it how to think. One commonly used method for this is called chain of thought (COD). Its logic is straightforward. When instructing the model, we include certain key phrases, such as solve this problem step by step and show me each process. With this kind of command, the model is forced to display its reasoning steps. This approach indirectly improves the model's reasoning ability. Another method involves using agents to enhance reasoning capabilities. For instance, we can design an agent system and define rules such as when to revalidate or modify answers until the desired standard is met. These techniques essentially enhance the reasoning capabilities of an existing model without altering the model itself. Techniques like COT and agents operate outside the model and were commonly used before the release of OpenAI's O1 model to solve reasoning challenges. However, these approaches often proved inefficient and incapable of solving highly complex problems. This limitation has prevented certain projects requiring advanced reasoning from being effectively addressed. OpenAI's O1 model resolves these issues by integrating reasoning capabilities directly into the model during training. Unlike external techniques that attempt to influence reasoning after the fact, the O1 model incorporates these abilities internally. When given an input, the model knows how to think, decompose complex problems into simpler ones, and provide a thoughtful response. Although OpenAI has not provided detailed information about how the model was trained, it's likely that a framework similar to self-play reinforcement learning was used, akin to the training methods for AlphaGo. This framework integrates techniques like COT and agents into the model's training, enabling it to understand how to think and solve problems by breaking them down into manageable components. The impact of this new model extends to prompts and other aspects. Previously, much of the reasoning logic was external, making prompts more complex. With the O1 model, much of the reasoning occurs internally, simplifying the prompts. However, this doesn't mean prompt engineering is no longer necessary. Experiments show that prompt sensitivity still significantly affects the model's performance. Even small changes in wording can yield different results, so fine-tuning prompts remains essential. This shift also introduces a new perspective on scaling. Traditionally, scaling laws focused on increasing dataset size, model size, and computational power to improve models. With the O1 model, however, the focus shifts to reasoning scaling, spending more time on reasoning processes to achieve better outcomes. As reasoning becomes more complex, the model's performance improves, but this also comes with increased inference times. For example, inference might previously take 1 second, but with the new model, it could take tens of seconds or even minutes. This significantly impacts real-time applications and raises costs, as reasoning processes generate large numbers of tokens that contribute to computational expenses. Compared to GPT-4, the cost of using the O1 model can be tens or even hundreds of times higher. Addressing these cost and efficiency challenges is crucial for commercialization. Future efforts will likely focus on reducing inference costs through engineering solutions, and professionals in this area are expected to be in high demand. Despite these challenges, the O1 model's advanced reasoning capabilities open up new possibilities, particularly in the field of intelligent agents. Current agents struggle with reasoning limitations, such as breaking down complex problems into subproblems or returning to previous steps when errors are detected. With models like O1, agents could become significantly more viable and practical. In conclusion, the O1 model introduces a new way of thinking for large language models by integrating slow-thinking capabilities. While there are still challenges to overcome, its potential applications are vast and promising. If you have any questions or thoughts, feel free to leave a comment below.